is a second example for 3.6 that you can use for your homework tomorrow. So again, we do want you to either watch this example or take notes. This will also be in a PDF form that you can print out. So we have three new equations in our system: a red equation, a green equation, and a blue equation that make up our entire system for x, y, and z that we want to solve for. So I've laid out the steps again to help guide you. So go ahead and write the three equations down. Step 1 is to add equations 1 and 2 together to eliminate the variable z. So first equation is in red, x plus 2y plus z equals 8. The second equation is in green, 2x plus y minus z equals 4. And I'm going to go ahead and add them together. When I add them together, I get x plus 2x is 3x. I get 2y plus y is 3y. And then positive z plus negative z, those cancel out. And then 8 plus 4 is 12. Now again, we're going to refer back to this black example in a little bit. All right, step 2. Step 2 is to use equations 2 and 3 together and try to eliminate the same variable z. So now I'm going to be working with the green and the blue equations. So the green equation is 2x plus y minus z equals 4. And then the blue equation is x plus y plus 3z equals 7. Now if I were to add the two equations together as they are, the z's will not cancel out. So I have to maybe change one or two of the equations. If I multiply the top equation, the green equation, by 3, then I'll have a positive 3 and a negative 3. So I'm going to change this top equation by multiplying it by 3. So now I'm going to go over here and do that. So 3 times 2x is 6x. 3 times y is 3y. And then 3 times negative z is negative 3z. And then our last one is 3 times 4, which is 12. And I'm not going to change the blue equation, so I'll just write that underneath. And now let's go ahead and add them together. 6x plus x is 7x. 3y plus y is 4y. The z terms will cancel out because negative 3z plus 3z is 0. And then 12 plus 7 is 19. Now look at step 1 and step 2, those black equations. 3x plus 3y equals 12. And this equation, 7x plus 4y equals 19. In both of those equations, we eliminated the z variable. Now we have a 2 by 2 system that we can either solve for x or y. So those are the two equations we're going to use in step 3. So I'm going to go ahead and write down those two black equations. 3x plus 3y equals 12. And then 7x plus 4y equals 19. Now we're going to use step 1 and 2, which we just did, and we wrote them down, and we're going to eliminate one of the variables. We're going to just choose to eliminate the x variable. So we're going to multiply the top equation. We're going to eliminate the y variable, excuse me. We're going to multiply the top equation by -4 and the bottom equation by 3. And what they will become is a positive 12y and a negative 12y. So we'll multiply this one by -4, the top one, and the bottom one by 3. So we get negative 12x, negative 12y, and then negative 48. And then the second equation, we get 3 times 7 is 3 times 7x is 21x. 3 times 4y is 12y. And then 3 times 19 is 57. Now let's go ahead and add those two equations together. So negative 12x plus 21x is 9x. Notice the negative 12y plus 12y cancels out, and then negative 48 plus 57 is 9. Now we're down to one variable, x, that we can solve for x. So what we do next is divide both sides by 9. So we have 9 divided by 9, so x equals 1. We've now found our first variable, x equals 1. Step 4 is to use one of your step 1 or 2 equations, those black equations that we found, and substitute x in and then solve for y. So what I'm talking about is either this 7x plus 4y equals 19, or this one over here, 3x plus 3y equals 12. I'm just going to choose this one. So I'm going to rewrite that using step 1, 3x plus 3y equals 12. And we're going to substitute that x equals 1 in to the equation. And now we have one variable to work with, y. So 3, replace the x with 1, plus 3y equals 12. Now we will solve this equation for y. So 3 times 1 is 3. Then we will subtract 3 from both sides. So we get 12 minus 3 is 9. And then last is to divide both sides by 3. So we get y equals 9 divided by 3, which is 3. We now have 2 out of our 3 variables identified. Step 5 now is to use one of the original 3 equations, either that red, green, or blue one, substitute x in for 1, y in for 3, and solve for that last variable of z. So here is my original system. And I'm going to just choose the top equation, the red one. X plus 2y plus z equals 8. So my original red equation is x plus 2y plus z equals 8. And I'm going to substitute x equals 1 in and y equals 3 into this equation. So I have 1 plus 2 times 3 plus z, which equals 8. Now I solve the equation for z. 1 plus 6 plus z equals 8. I'm going to add like terms together. So the 1 and the 6 becomes 7 plus z equals 8. And then I'm going to subtract 7 from both sides. So 8 minus 7 is 1. Now I have all three variables identified. So identify the x, the y, and the z, which equals x we found to be 1, y we found to be 3, and the last one, the z, we found to be 1. So the solution to this system for x, y, and z is 1, 3, 1. Think back to when we graphed those ordered pairs in lesson that we did yesterday on 3-5. What your homework is for tonight is problems on page 224, number 3, and then 8 through 10.